Okay. For those of you who are familiar with Chad's work, you'll know that he is very careful about measurement in his research. He's not one of these academics who just downloads a data set and uses it without questioning whether it has been measured properly or not. And this is a great strength, I believe, of Chad's work, and it's one of the reasons why we think he's an excellent keynote speaker to have at this particular event. One other thing that he's apparently very good at is alliteration, as you can tell by the title of his talk today, Productivity Patterns, Present and Prospective. Without further ado, please join me in welcoming Chad Syverson.
We have to click on the one. There we go.
Okay.
So the productivity slowdown, to me, is the economic problem of our time. Here's a picture you've probably all seen. This is from the Conference Board's Total Economy database. Breaks out, greatly smooths, but shows average productivity growth rates for the past several decades for differing sets of economies, including basically the world overall, which is the blue solid line there. Regardless of where you look, there's been a decline in average productivity growth in all economies in the world for at least 15 years, maybe longer, depending on where you're looking at. And this is, of course, a big problem because productivity is the speed limit on economic growth. It is the only way we can get sustained increases in material well-being. And it's one for one, basically, in the long run. So if productivity growth slows down by, say, 1% per year, we should expect GDP per capita growth to also slow down by an amount of 1% per year. So to give you an idea of what 1% means, if we could get an extra 1% productivity out of the world this year, that would be another 800 billion pounds, or 100 pounds per capita, which, if allocated evenly, would alleviate a massive amount of poverty. Either way, it's a lot of output. If just the UK could increase its productivity by 1%, that would be about 400 pounds per person in the UK. So that's real wealth, and that's 1% for 1 year. So if you've got a larger slowdown than a 1 percentage point slowdown in productivity growth, it's more than that. And if you sustain that over multiple years, of course, that compounds and it becomes quite large very quickly. And that's why a slowdown, and I'll show you, in the neighborhood of 1% per year, or maybe even larger, lasting for 15 years or even longer, is a real concern. Okay? We also have other economic problems we're dealing with, maybe still some inflation, lots of distributional issues. That's not to say those don't matter, but I think it's useful to remember that productivity growth makes everything easier. Okay? It rather than having to deal inside the constraint, it actually loosens the constraint. It's the giant Lagrange multiplier on our lives. And if we can get productivity growth up, all these other things that we struggle with from day to day also become more soluble. Okay, the UK has been no exception to this worldwide productivity growth slowdown. In the top row there, I've got some average productivity growth, labor productivity growth numbers for the UK over some periods, which I'll talk about in a second. And I'm comparing them in other rows to various collections of other economies. The first two columns are sort of the before and after picture. So you've got 95 to 2004. That was a decade of relatively strong productivity growth throughout the world. Then you've got 2005 to, well, as close as we have data for, that's comprehensive, 2022. So that's sort of the period when about when the productivity growth slowdown started and has continued through. And then I've broken that out into some specific time periods, one excluding the worst years of the great financial crisis, lest you think there's some measurement issues tied to that, or just other volatility. And then another one showing the COVID years specifically. It turns out that the story is the same of those three rightmost columns. Basically, the entire after period looks the same no matter how you slice and dice it. And what you see then comparing, say, the first to second column of numbers there, you can see the slowdown I'm talking about. And it is in the neighborhood, say, for the G7, the OECD, the EU, and the US of 1 percentage point per year. Okay, so that's that amount compounded year after year after year. GDP growth has probably been 1% slower than it should have been otherwise for that entire period. You can see in the UK, however, it's actually been larger. Okay, so it's been more than 1.5% per year. And I'll talk about what's happened in the US in the past couple of years specifically. We're not seeing that sort of return to trend in the UK yet. So if anything, all these issues with the productivity slowdown are even more salient for the UK specifically. This means, by the way, that the UK had been converging to the productivity frontier in the world, which I'm using the US for. I think that's a reasonable metric for that. It got as close as, this is PPP adjusted output per hour as a percentage of the US shown here. And you can see it got up to about 93% of the US in 2000, 2001, but since that time it's declined back to in the neighborhood of 80% because of the relative productivity growth differential you just saw in those numbers there. So it's receding from the frontier, not just has it stopped converging to it, it's actually receded from it in the past couple decades. Okay, so that's a little bit of the problem. I'm not a doomer and gloomer, but if there is a doom and gloom portion of the program, that was just it. Okay, I want to turn this around a little bit and talk about what the optimistic case is. Okay, and I want to be clear, it's a case, not a prediction. Okay, I am not saying I know with some probability productivity growth will increase by some given amount, but it is a data-driven case. And I'm going to talk about patterns in the data that I think are encouraging about future productivity growth. So it's not just not liking the way things are going and making up a story, but rather going to the data and drawing out some changes that I think are important to recognize. Okay, so first, if you just look what happened through COVID in the US, and again, this has not happened so much in the UK. What you saw was an initial surge at the beginning of the pandemic, and then basically a couple years of either flatline or receding measured productivity. And the past years, though, there's been a re-acceleration. All of that has basically gotten us back to the trend that we were on pre-COVID. So if you just extend out the 2019 numbers at the average productivity growth sustained from 2015 to 19, you get that dashed line there, and you can see we're basically back at it. Now, do I think all of these wave motions here were real productivity movements? No, they're quite likely the typical composition and selection-driven changes in productivity numbers we often see through cyclical periods. I think that's what was going on. So we seem to have worked through all of that and are back on trend. The interesting thing is the past year or so, last quarter notwithstanding, we have been seeing productivity growth that's been faster than the 15 and 19 trend. That's how we got back to the trend after being under it. The real question going forward is, now that we're back on trend, will we slow down and stay on trend, or will this past year of faster than 2015 and 19 growth continue and will actually accelerate through the trend? Okay? And that's obviously the big question. That's the thing I'm going to be looking at very closely over the next 4 to 5 quarters. But again, I think there are some patterns in the data that are at least encouraging about the prospect of the latter scenario, where we actually accelerate through the trend rather than just return to it. Because remember, of course, the trend was the post-productivity slowdown trend. It wasn't a great trend. It was a historically poor trend. So we'd like to be above what the pre-COVID trend was. Okay? And I think the core, well, I guess the case has 2 elements. One element that's, I think, very important, especially in the short run, is tied to a resurgence in dynamism. Okay, so just as a matter of facts, almost all metrics of economic dynamism, at least in the US, although I think this is generally true, maybe with a shorter lag period or shorter history is a better word, for other OECD countries. There have been long run declines in metrics of dynamism. Things like churn rates in labor markets, so total job creation plus total job destruction, and just how much people are moving around from job to job. First of all, the simple fact is, as you probably well know, is that these gross flows are far exceed net flows. Okay, so in the US, a good job month, creation month would be 200,000 net jobs created. Okay, well, that 200,000 net is actually the difference between 6.1 million jobs created and 5.9 million jobs destroyed. Okay, so that 200,000 new jobs that people think of, oh, that's what we're adding every month, that's actually hiding huge gross flows in each direction. Okay, so the amount of churn is huge, and that's not just true for labor markets, that's true capital markets and a lot of things you can look at in the economy. There's plenty of churn. All that said, as much churn as that is, that's actually been in long run decline. Going back at least 3, maybe 4 decades, the amount of labor market churn's been going down, business formation rates had been falling steadily for decades, so on and so forth. And in fact, some people were tying the productivity slowdown to this reduction in dynamism. Okay? And then maybe they had stories about why dynamism was declining and therefore causing the productivity slowdown. Either way, that seemed to be a clear pattern in the data that at least lined up with the productivity slowdown of the past 15 years or so. Well, as it happens, after decades of decline, those metrics have turned around since COVID. Okay, and it's not just in the US. I've got some numbers here for the UK, but you can find other things for other countries in the OECD, for example. So if you look at gross job flows rates, for example, average hires plus separations rates, that's gone up since before COVID, and that's after, again, remember, decades of decline. So it's actually turned around and started increasing again. One metric I like a lot is the quits to layoff ratio. So when you separate a job, separate a worker from a job, it either happens voluntarily, the Bureau of Labor Statistics calls that a quit, or involuntarily, that's a layoff. The ratio of quits to layoffs last year was at a long-time historical high. In fact, it was considerably above what it had ever been at before. Most people departing from their job were doing so voluntarily. Now, some folks use that as a measure of labor market tightness. That's fine, that's not really my area. I use it as a measure of potential productivity growth, because another thing we know is all this churn that I was talking about, at least on average, tends to raise productivity because it, on average, moves resources from less efficient to more efficient producers. And that is true in particular for workers. I've got a paper with some co-authors in Chile using Chilean data, and we show this fact exactly, that most workers move from a less efficient, less productive firm to a more productive firm. Okay, so churn, especially voluntary churn, is apt to be tied to workers moving from a lower productivity employer to a higher productivity employer. So I view that metric as a sign of productivity enhancing labor market reallocation, and that's gone up. It's not quite as high as it was a year ago, which was crazy high, but it's still much higher than it has been historically. Okay, something akin to that, we don't have a quit to layoff rate in the UK, or at least not that I know about, but the job to jobs flow rate, that's also gone up. So people directly transitioning from a job to another job, not going through, say, a period of unemployment or non-employment. We also find that in our Chilean paper, by the way, that the highest productivity gains are for job to job transitions, not with a period of unemployment or non-employment between the two jobs. And the biggest thing And this has been, I think, a big surprise to everyone, and I don't think we fully understand what's happening yet, is that business formation rates have gone up. They've gone up a lot in the US. They've gone up 35%. So there were 5.2 million businesses formed in both 2022 and 2023. That's a lot higher than it was before COVID. Okay, and this isn't just some manifestation of work from home. People are tired of going into the office, so they start their little consulting company in their spare bedroom. Because you can look at the data in different ways. First of all, it's across a bunch of different sectors. It's not all kind of clerical or office-tied work. There's a lot of business formations in sectors where there basically aren't a lot of work from home possibilities. Plus, there is a model that the Census Bureau has that predicts business formations that have a high propensity to turn into fast-growing employer businesses. And those kinds of startups have gone up almost as much as overall business startups. Or even just a softer metric, but more direct, how many businesses start with a paid employee? That's also gone up by the same amount as overall business starts. Okay, so I find this a very encouraging stat, which again, the business formation rates have been declining for decades before COVID, yet we're coming out of COVID with hugely higher business formation rates than before. And that's also true, by the way, in the UK, at least for the 2022. I couldn't get the 2023 data for new LLCs formed, but you can see it's higher than it was in the pre-COVID period. Okay, so all of this new dynamism and the stopping, if not the actual turnaround of the trend in declining dynamism, I find to be a source for productivity optimism coming straight out of the data. Do we have direct evidence that it's increasing productivity yet? No, but I think if you put it together with other things that we know about churn in markets, I think, again, there's real case for optimism here. Okay. Another thing you see, and I took this from a paper who I wouldn't be surprised if some of the authors are in the room here. This is for the UK and shows basically that a concern about this relationship between churn and productivity enhancing churn was that the COVID forbearance programs, which had many good arguments for them, nevertheless might have sort of thrown the sand in the gears of that process and therefore stopped the productivity enhancing churn that we often see. That seems to not be the case. Okay, it's not to say that productivity growth was positive. So what I want you to compare here is the within firm productivity growth. So this is overall productivity growth in this sample of firms. Within firm growth is productivity growth inside a firm. The between firm growth is productivity growth coming from changes in the amount of activity across firms. So you get increases in productivity if you have that in productivity enhancing churn, if the markets are moving activity from lower productivity to higher productivity firms. The blue parts of the bars show the between firm effects. That's the churn stuff. And you can see that throughout COVID, that was actually positive. Okay? It's declined in size, okay, but it's always been positive. It's not that this process that I mentioned of churn on average helping productivity out stopped or was reversed during COVID because of the forbearance programs. So I also found that to be a bit of an encouraging sign. Now we're obviously out of all those programs, but it doesn't look like they did any lasting damage to the way the economy moves inputs and outputs across itself. Okay, now let's talk about what everyone is talking about with future productivity growth. And maybe it's tied to some of those things like churn and business formation. I think that's yet to be determined. And of course, that's artificial intelligence. Is this the thing that's going to get us out of the productivity slowdown, or is it already getting us out of it and we just don't know it yet? Okay. And what measurement issues might arise if it is the next general purpose technology and therefore is the most likely candidate to get us out of the productivity slowdown. So I'm actually going to focus on this third question the most in the next several minutes, but of course it'll reference those other two questions as we go along. And this third question was sort of the focus of some work I did with Eric Brynjolfsson and Daniel Rock on measurement of productivity in the face of new general purpose technologies. And the thing we pointed out in this work, this is the productivity J-curve stuff, if you've heard of it, is that general purpose technologies, by definition, induce a lot of complementary investments. Okay, that's one of the definitional elements of a general purpose technology. If, as we think is plausible, a lot of those complementary investments are actually intangibles, then there are important implications for productivity measurement when there are new general purpose technologies, like AI might be. Okay? So if you just take a step back and think for a second, okay, how would intangibles tied to general purpose technologies affect productivity measurement? Well, of course, all productivity measures are some ratio of outputs to inputs. There's a couple ways that intangibles can affect that. First of all, intangible capital would be an unmeasured input. You're using it to make stuff, okay? But you're not counting as an input. So in that world, you're undermeasuring inputs and you're describing what people view as a lot of output coming from not much inputs as, well, that's because you have really high productivity. But that's actually a mislabeling. It's the marginal product of capital. It's just capital you're not measuring. It's intangible capital. Okay, so you tend to overstate productivity because of this missing input issue tied to intangibles. I think most people are comfortable with that intuition. That's usually the first thing folks think of when you think about intangibles and productivity measurement problems. Okay? But the other thing to recognize is when you first make that intangible capital, it's an investment good. And we count investment goods as output, or we ought to. But if it's intangible, you don't count it as output. Okay? And so because of that element, you're undermeasuring the numerator, not just the denominator. And so you can undermeasure productivity as well. So you have problems in both parts of the productivity ratio. You're understating inputs, but you're also understating outputs. Okay, so how that nets out, of course, depends on the relative size of the mismeasurement of each of those. Okay? So we work through this just using a standard growth accounting framework. Okay, so we start with how things are usually done. You've got, this is all in value added. So output is some function of capital labor. You've got some TFPA. We all know how to construct a solo residual out of that. That's what we usually call TFP. It's just the growth rate of output minus a weighted sum growth of capital and labor inputs, where each weight is the factor's income share. Okay? And then we compare that to a world where you could keep track of all these intangibles that you're supposed to in concept, but we don't. Okay? And first thing to recognize on the right-hand side, you've got that intangible capital, we call U, that's used as an input. That's the first measurement problem. You're using that stuff as an input, but you're not putting it into the denominator of productivity normally. Okay? But then on the left-hand side is the output measurement issue, which is when you make that intangible capital, the investment into the intangibles, which we call I sub U, okay, and the relative price of that intangible capital compared to tangible output is phi. Okay? You should be counting that as output, okay, but you don't do that either. So you've got a problem on both sides of the equation. If you could measure all this, you could construct the analog to the solar residual in the intangible world, and it looks like that. Okay? If you take the difference between these two, you can get some really nice intuition popping out, which is what is the difference between measured productivity as we usually do it, that is the solar residual, and true productivity growth, which is including both the outputs and inputs tied to intangible capital. There's a number of ways you can do this decomposition. Different ones offer different intuitions. You can go through them in the paper. I'm just going to talk about two really quickly. one being the one at the bottom of this slide here. You see this first term, this is intangible capital investment that's being made by tangible inputs, capital and labor. This is the output that's missing. Okay, you want to be counting that intangible capital. And just to fix ideas, what am I talking about? When you train workers how to use AI models, when you reconfigure your sales organization to take data and put it into the AI and then learn stuff from what the AI tells you about your customers, what they want, when they want it, where they want it. All of that reconfiguration, most of it anyway, is not going to be put on the books as an investment. That just gets expensed. But it ought to be conceptually an intangible, conceptually is capital. It's just intangible because of the way we measure things, okay? So all of that stuff, when you do it, you should think of it as you're making capital, but we just usually book it as expenses. And so you can see it's got a negative sign in front. You're understating true productivity growth because you're missing all that output you're creating. Okay, so that's the first term. The second term is the contribution to measured output, so not the intangibles that you're making now, but the tangible stuff you make, of the intangible capital stock. So this is the undermeasured inputs. This is the denominator problem. And you can see that's got a positive sign on it. This causes you to overstate true productivity growth with the solar residual. And again, that's just because you're attributing to productivity what is really the product of intangible capital inputs. Okay? And then the third term is a compositional term. It's the growth in the measured share of output. So if you think intangibles are becoming more important in the economy, that's actually negative. And in that world, you would expect another source of productivity undermeasurement, because again, basically the problem of measurement's getting worse over time because intangible share of output is growing. At first, we thought this would be basically rounding error, but you put some numbers on it that I think are reasonable, you get a few tenths of a percentage point. So that third term can actually matter too. Okay, so that's one way to think about the intuition of the measurement problem. Another way is if you apply general practice, which is people don't measure capital income directly, they just measure it as 1 minus labor share of income, labor share being easier to measure. Then you get that the true productivity growth is basically a weighted sum of the solar residual, where the weight is the tangible share of output, so 1 minus eta, plus the difference between the growth rates of the two capitals, weighted by intangible share. So that's also, I think, a helpful intuition. And one thing to see there is, if those two things are growing at the same rate, that second term goes away. Okay? And then you just have a steady mismeasurement of true productivity growth. Okay. So all of that's about doing the growth accounting. This thing can be bigger than that. This thing can be bigger than that. Could be positive, could be negative. The math doesn't tell you what the likely temporal path is going to be of mismeasurement. But the economics does say something about it. And the basic intuition is you got to make intangible inputs before you use them as an input, sorry. So first you understate output when you make that stuff. Later, as you can increasingly put it into production, then the input measurement problem gets worse and you start overstating productivity. So first you have undermeasurement, later overmeasurement, and hence the J curve. Okay, this is what pops out of a little toy model we have in the paper. I wouldn't take the numbers too seriously. They were picked to be quasi-realistic, but not carefully done. And this is just to demonstrate the kind of dynamics that can happen. You have a period of undermeasurement and then a longer tail of overmeasurement going off into the future. One thing to notice, though, is that the year scale, that's actual years. You can have decades of undermeasurement before you have decades of overmeasurement. Okay? Now, do we know it's exactly 16 years of undermeasurement? No, I don't take the numbers that seriously. But could it be a long time? Yeah, it could be a long time. I think the numbers were realistic enough to figure that you can be in this world of productivity undermeasurement at the beginning of a new general purpose technology for quite some time, multiple years. Okay. So we actually try to put some more specific numbers on things by doing a trick, which is to say, look, we're not sure about AI going in the future. We sure don't have data on it yet, with one exception that I'll get to in a little bit. Okay, but what we can do is look at past technologies where we think intangibles might have been, intangible complements might have also been important, but where we can measure those technologies, we'll go back and pretend like we couldn't measure them, do the solar residual acting like they're not there and we can't measure the intangibles associated with them, and then compare it to what actually happens when you use the data that we could see after all. Okay, so we're going to do that with 3 different kinds of technological inputs: R&D capital stock, so capitalized R&D flows, computer hardware, and computer software. And each one will give us a look at a J-curve of its own. Okay. And just to get some sense of how big these things can be, how long they can last, et cetera, et cetera. The first thing we did is with R&D, we had to figure out how much intangible was associated with each dollar of R&D investment. Okay? So we did what's been done by other folks in the literature as well, is you regress for publicly listed companies market values on their capitalized R&D stock. And you just ask how many dollars does the market value $1 of R&D stock at? If that number is higher than $1, that implies there must be some intangibles associated with that R&D that the market's also valuing. Okay? And this shows a set of regressions like that: market value on capitalized R&D stock, along with the actual PP&E, that is the tangible capital stock. That's total assets in the top row there. Okay? First thing to notice is the coefficients in every specification on total assets is about exactly 1. That is, if a company has 100 billion more assets than it had before, all else equal, its market value will be $100 billion higher. Okay? The market seems to value $1 of physical assets at exactly $1. Okay? So that's a feather in the cap of my colleague Gene Fama and his efficient markets hypothesis. Okay? R&D stock, on the other hand, has a coefficient bigger than 1. $1 of capitalized R&D spending is valued more than dollar per dollar. In fact, it's valued closer to somewhere between $1.50 and $3. Okay, that suggests there's somewhere between 50 cents and $2 of intangibles tied to each dollar of R&D capital stock. We're just going to use 2 for our purposes, so a coefficient of 2. So that means for every dollar of R&D, there's basically another dollar of intangible capital that's complementary to that R&D, that the market knows is there and values as such, but isn't put on the books by our accounting standards. Okay? So we're going to construct an alternative TFP measure using the notion that for every time we see $1 of R&D, we are also seeing another dollar of intangible capital being created. And then we'll do the growth accounting for that and see what changes. Okay? And if you do that, this is what you get. So the measured solar residual, not trying to account for these intangibles, is the orange line. The corrected one, which does account for these intangibles, is the blue one. And at this point, you're squinting, saying, well, where's the blue one? And it's there, you got to look, but it's just kind of tiny deviations off the edge. And at this point, you're saying, well, okay, that was a nice conceptual windup, but if in the end, this is all that matters, is this that important? Okay? And this is where I remind you that if you're at steady state, the J-curve is an intertemporal measurement problem. You understate, then you overstate. Eventually, you come back to getting it right, even if there's intangibles the whole time. Why? Because on a balanced growth path, the output problem is the exact same size as the input problem. So the 2 mismeasurements just cancel each other out. Okay? So in terms of growth rates, you get everything exactly right. Okay? And what basically seems to be going on here is that, at least for R&D associated intangibles. The J curves long since happened already. Okay, we've gone through the under measurement and over measurement stages, and now there might still be intangibles tied to R&D, but we're mismeasuring them equally in both the numerator and the denominator, so it's not actually affecting the productivity growth rates we're measuring. Okay? So that's the R&D story. Things change a little bit if you look at computer hardware, and supposing that there are some this just shows the standard productivity index. So this isn't growth rates now, this is the integral of the growth rates. The index of TFP, unadjusted is the purple line, adjusted is the blue line. You can see they're basically on top of each other. That's just because the growth rates are essentially the same. But if you break it out into, let's ignore the numerator, let's ignore the denominator, those are the green and red lines. And you can see they're there. It's just that they basically are the same size and opposite signs. So again, they cancel out. Okay, so now let's move on to the same exercise, but doing it with computer hardware instead of capitalized R&D. Here we're going to use a much larger value of implied intangibles tied to each dollar of hardware investment. We're going to use $10 because Eric had done some work earlier suggesting a number that high, but we worked through everything in the paper using $5, $4, $3, and $2 as well. Okay. If you now do the same exercise, well, first thing you can see is you can see more blue. Okay, so it starts to matter more. It only matters later on in the sample because computer hardware investment was pretty tiny. That's another lesson. You can have a J-curve problem, but if the actual intangible investment's pretty small, it's not going to affect aggregates. Okay? It starts affecting aggregates in the mid-1990s. Okay? If you integrate those productivity growth rates, you get pictures like this. The unadjusted series, not accounting for the intangibles, again, is the purple. The corrected series is the blue one. And then again, the green and the red break out the numerator problem and the denominator problem. And now you can see by the end of the sample, there's an actual gap that we are truly under measuring real productivity because we're not accounting for these intangibles tied to computer hardware investment. And furthermore, at least to this point, it's mostly been under measurement because we haven't had enough of the over measurement to bring the two series back together like it had for R&D. Okay, so this just breaks this out using different values of intangible per dollar of hardware investment, 10, 5, 3, 2, and unadjusted 1. Everything just scales up with the amount of intangibles you assume. In sum, the numbers imply we're understating productivity by about 4% because of mismeasurement specifically tied to intangibles related to computer hardware investment. Now that's 4% accumulated over 50 years. So it's not too much every year. So this isn't a problem on a year-to-year basis, but over time, it seems to have accumulated. Okay? As I said, we kind of know we're not too far along the top end of the J curve because we haven't seen the numbers, haven't seen the two series return to each other yet. And actually you can just plot the differences in those growth rates. You get a picture like that. If you then integrate the differences, which is just the total vertical gap in that series there between the blue and the purple, it looks like we're at the bottom of the J curve for computer hardware. And we would expect in coming years, it'll start rising again, and maybe in a decade or so, we're actually going to be overstating productivity specifically because of intangibles tied to computer hardware. Okay. Finally, I'll just quickly show you the pictures for software. You can see software investment starts showing up in the aggregate somewhere in the late 80s, maybe early 90s. Also has created a widening gap between adjusted productivity and measured productivity that ignores the intangibles tied to that software investment. It's larger than the gap for hardware, which was about 4%. Here, the accumulated gap over the past 50 years is about 12.4%. Okay. Now, to be sure, every technology out there that has any intangibles associated with it can have its own J curve. Okay, so I wouldn't just take these numbers and say, oh, we know productivity is 16% too low, 4 plus 12, because there are other technologies that might be on the top end of their J curve, and we're overstating productivity specifically with regard to intangibles tied to them. So we don't know what sort of the aggregate total adjusted J curve is, okay? But because we have all of these potential technologies with intangibles associated with them. So, you know, whatever, you've got a bunch of staggered J curves going on. What matters for aggregates is like if you come with a brand new technology that has a lot of intangibles associated with it and itself is a large share of investment, like AI could be, then that J curve can start swamping any other J curves and it drives measurement dynamics overall. And that's kind of the thing that we suggest in the paper might be something we want to keep an eye out for, because AI might be a technology like that. Okay. Now, if you actually go and do some back of the envelope calculations, you can get a sense for how big the J curve tied to the AI might be right now. So in the US, we don't have great data on this, but estimates of AI investments seem to be about $75 billion in 2023. So these are direct measured investments. Suppose each observed dollar of AI investments were correlated with $2 of intangibles, which I think is kind of on the small end of things. That would say that, well, there's 150 billion extra dollars of output being created that we're under measuring. That's more than 0.5% of GDP. So we might be understating true output by 0.5% just because of AI right now. Okay? And AI investment rates are growing very quickly. So if AI investment becomes, 5 times as large as it is now, pretty soon this stuff can really start mattering. Will I guarantee it's going to start mattering? No. But I think this suggests this dynamic, and the fact that AI might be the next general purpose technology, and it's not hard to imagine that there are a lot of intangible investments already being made associated with it. I think it's something we'll have to keep an eye on measurement-wise going forward. By the way, all of these J-curve dynamics don't seem to explain the productivity slowdown at all. If you look at the adjusted series that we created for either for hardware or software and compute the implied productivity slowdown, it actually gets larger. Okay, so remember, if you're going to explain the productivity slowdown with a measurement problem, you can't just say, there's a measurement problem, we're done, that must be the issue. You need a measurement problem that gets worse at a particular time. Okay, you need all those to go together, and that doesn't seem to be the case. There was not a sudden change in J-curve dynamics in the mid-2000s that would have going in a particular direction that would have exacerbated the productivity slowdown. Okay, so that's kind of the big picture. Now I want to narrow in a little bit on some industry-specific stuff that I've been looking at. I'm going to be leaving about at least 15 minutes for questions, by the way. Just to give, aggregates are, of course, the integral of a bunch of industry-specific dynamics. So you can learn about the mechanisms driving some aggregates by looking at the micro data sometimes. And that's what I've been doing now, especially with my colleague Austin Goolsby. We're actually starting on a project looking at a series of industry productivity patterns. We've done 2 so far. The first one was the construction sector, which exhibited a pattern that we called strange and awful. Okay? Here's what's happened to productivity in the US construction sector in the last 70 years. The blue lines are productivity for the overall economy. The solid line is labor productivity. The dashed line is total factor productivity. There we find the typical story, which is regardless of accelerations and slowdowns of those rates, they're on average positive and productivity grows over time. In the construction sector, shown with the red lines, again, solid for labor productivity, dash for total factor productivity. For 20 years, 1950 to the late 60s at least, that sector exceeded the overall economy's average productivity growth rate. But then something happened and it slowed down. But it didn't just slow down, it actually turned negative. And it didn't just turn negative, it stayed negative. It stayed negative for half a century and still has. This goes to 2020, but it actually gets worse if you include the COVID years. Okay? Productivity growth in the construction sector has been negative for the last 50 years. Measured productivity growth. Okay? So not just underperforming the economy, but underperforming stasis. Okay? So what's going on? Well, we wrote a paper. I think we can rule out this isn't some underinvestment problem. Details in the paper. It's not due to construction inputs becoming bizarrely more expensive and harder to obtain than factors in other sectors. It's not about high margins and market power. It is in an accounting sense about the construction deflator. Okay? If you use the GDP deflator to deflate nominal construction output, productivity growth isn't negative anymore. It's positive. It's not quite as fast as aggregate productivity growth, but it is positive. So just in an accounting sense, this negative growth is coming from the deflator. Okay, that doesn't mean the deflator is wrong. Okay. Maybe it's right, but we know that's where the issue is, somewhere in this deflator. So the key question is, all right, how well do we think that construction deflator is actually measuring true price changes, or is it confusing quality changes for price changes? That'd be the biggest thing you'd worry about, right? The quality of built stuff is getting better and better. It costs more for more quality, but the price index doesn't adjust for that. It just says, oh, the stuff costs more, and therefore you get the same thing, but it costs more than it did before, and real output's gone down. So one thing we did is say, well, let's go look at part of the sector where we don't need to worry about a deflator. And that's because we have this helpful element where they actually count the number of houses that are built, regardless of what they sell for. So if you look at number of houses built per worker per year in the housing construction sector in the US, there's multiple series. Here they are. Since 1990, they've been broken out into multi-unit and single unit. Multi-unit's the red, single unit, detached housing, that is the blue. They were combined before in another series. Either way, you can see that's not going up. And in fact, if you fit trend lines, they're negative. At best, they're flat. Now you can say, well, maybe houses have got better. They've certainly gotten larger. Okay, let's look at square feet built. Sorry, square meters, for now that I'm in Europe. Square meters built per worker per year in the housing sector. Still flat. One maybe upturns a little bit in the single family housing. But even there, it's like 0.5% productivity growth per year, which is considerably underperforming the already slow productivity growth in the overall economy. Okay? There are other quality issues. We did some light adjustments for those, but if you really want to see it done well, go read the paper by Daniel Garcia and Raven Malloy at the Fed. They really tried hard to come up with a quality constant metric of housing built, and they basically find the same thing. Even giving as much quality credit as you can to the housing sector, they don't seem to be getting much more productive at building houses than they were 50 years ago. Okay, so, and again, there's no deflator measurement issue here at all. So even in this world, we're not seeing signs that really the sector's doing fine and we just have a measurement problem. It seems to be at least partially the construction sector just isn't any good at what it does, and maybe it's getting worse. This isn't just a US problem, by the way. There's 29 countries that the OECD has data going back to at least 1995 for in the construction sector. 16 of those had average productivity growth over the quarter century, at least, that were negative. Okay, and the overall average is positive but tiny, considerably underperforming the economy-wide productivity growth again. So something is sick about the construction sector in a lot of countries. We don't know why. I've been spending a lot of time talking to people in the industry. I was just telling Kevin before the talk. I found them amazingly receptive to the notion that there is a problem. It's not a, usually there's a little denial, but it's over in 5 minutes. And then they kind of admit, okay, but it's not clear we know what to do yet. But knowing you have a problem is the first step to solving the problem. Okay? A little less strange and awful pattern is found in a different sector Austin and I are looking at, and you are the first audience to see this picture besides me, Austin, and our research assistants. The eating and drinking sector, restaurants and bars, had flat productivity going back as far as we had data for, which in the US is 1992. Okay, so this is real sales per employee, although I could show you per employee hour, the story's going to be the same. Real sales per employee for the restaurant sector. It's been basic little bops up and down, but basically $80,000 since 1992 until COVID. There was a huge negative shock at the beginning of COVID for obvious reasons. But then at the emergence from the pandemic, it popped back up, but it didn't stop at 80,000 where it had sat for the 30 years prior. It kept going. It rose above 90,000, somewhere in the neighborhood of 92,000, and it's been there for the last year and a half. So somehow the sector got about 14, 15% more productive coming out of COVID. Okay? We're kind of the first people to point this out. We're trying to figure out what happened. We got some micro data on restaurants and restaurant traffic. One thing that seems to be showing up in the data is that restaurants that reduce the average dwell time of their customers, so we have phone tracking data. We know how many people go into the restaurant and how long they stay there. That's dwell time. Restaurants that reduce their dwell time, their average dwell time, see their productivity go up. So this is the coefficient from a regression of restaurants' labor productivity on the average dwell time for its customers in that month. There are restaurant fixed effects in here. So this is all within restaurants over time. We've got month-year fixed effects, so taking out any aggregate changes. And you see this negative coefficient, which is to say, if average dwell time goes down, your productivity goes up. Okay, how can average dwell time matter? One is, it could be a reflection that you're doing takeout, and takeout is a way to sell more stuff with fewer inputs. Okay, it could be that you face capacity constraints less often, you're turning tables over more. So you don't have to turn people away, or people don't walk up, see your crowd, and go somewhere else. There's a table for them instead. That's another possible mechanism. To quantify what this coefficient means, we can take the observed change in dwell time, and that's shown here. So it was about 30 minutes before the pandemic. It has fallen off now to about 25 minutes, average dwell time. Okay, and if you see the look at the distribution, there is a bimodality there. It's clear that takeout has gone up a lot. Okay, if you take this change and just multiply, or take this level, multiply it by the coefficient I just showed you, that gives you the implied productivity growth coming from the change in dwell time. And you can see that over the sample, it ends up being about 20%. Right? So you can explain, just in an accounting sense, the aggregate change in productivity coming from reductions in dwell time. There are some other mechanisms we're looking at, but this one seems to be popping out of the data pretty clearly. Okay, so there's an encouraging bit of productivity news for you. We're looking at still other sectors. We just started in earnest on those, and I hope to be sharing that stuff with you in the coming months and years. Okay, so after all that, where does it leave us? I don't know. Honestly, I'm not sure. But that's the fun part of my job is the fun part of all of our jobs, right? We're explorers, okay? We get to think about what we want to think about and play around in data to try to figure out how the world works. Okay, so thanks for doing all that. Thanks for making the data available for other people like me to do all that. And let's all go have fun trying to figure it all out together. I will say I'm as optimistic as I've ever been about the productivity growth slowdown ending. Doesn't mean I know it's going to end. I think there's a positive probability it won't, but I think my own subjective probability that it will is as high as it's ever been. Okay. What I do know is there's plenty of work left to do, and events like this and the stuff we're going to talk about in the next couple of days help shape our plans for what we're going to do. So enjoy your time here, and thank you for listening.
Please raise your hand. We've got people with microphones. Please speak into the microphones when you ask a question, and it would be nice if you introduce yourself as well. Question down here, I think it's the first hand.
Thank you. So my name is Katsushi Mai, from Manchester. Thank you for your super interesting and inspiring talk. So my question is regarding your story of the intangible factor of the article, which is mainly relevant to the IT sector. So concerning your argument to the empirical or measurement issue, so do you think there is a spillover effect from the IT sector to other sectors at various levels, which would probably affect the measurement of the capital and output for non-IT industries as well? So if that is the case, so perhaps your story on the under measurement of the productivity would need to be more emphasized. So that is my question.
Okay, so let me just say, I agree with you. There probably are spillovers, and some of them are probably across sector. That's not going to change the aggregate exercise we did, because we just said for every dollar of IT investment, whether it's hardware or software, there's another $1, $2, or $5 of intangibles out there. We didn't have to say what sector it was in when we did all that. So for aggregate measurement, it wouldn't, the cross-industry spillovers wouldn't matter. Now, if you want to compute the productivity of a particular sector, now that allocation matters. We haven't tried to figure that out. I would not be surprised at all if the size of the spillover was heterogeneous across sectors, and therefore you'd have to be careful and be thoughtful about how large the spillover was when you allocated these intangibles across sectors. Yeah.
The next hand I saw was well, let's go off the back to the lady.
Thank you. You said that productivity is speed limit because it deals with well-being. And I was wondering, I would say carbon productivity maybe is a speed limit in an existential way, and how will it maybe carbon adjusting some of the inputs that we use to those numbers would change sort of some of the things that you've shown. Do we really need increases in material well-being, or do we need better distribution of the proceeds of growth that we've seen in the last 20 years? And I guess, what do you think is the role of economic rents in the productivity story that we've shown?
Okay, so yeah, a few questions there. First, I would say material, I chose that specifically. Okay, so there are other notions of well-being that aren't tied to GDP. Fine. I will say, I think the only way we decarbonize is through continued technological growth. So I sort of would expect decarbonization to be correlated with TFP growth going forward. And we need TFP growth to decarbonize more quickly, let's put it that way. Yes, there are distributional things that matter too, but again, that gets to the point of the more resources you have, the less you are constrained when you do reallocate. So it makes all the trade-offs that political fights are over get loosened when you have more resources. So I sort of view there's always distributional issues. All else equal, I'd rather have more resources to redistribute than fewer. But that's not to ignore that there's other stuff that matters and that GDP is far from perfect as a sole metric of welfare. That I certainly don't agree with.
Okay, next question, Barnes.
Thanks, Jet. Great talk. Thanks for setting out the productivity J curve again. It's tough, so it's good to sort of see it explained again to really understand what's going on. You presented it very much as an accounting story, which is, of course, the way it came out in the paper with Eric. But there's another story to this, and that is that there might actually be a real J curve in the sense that it's the time lag hypothesis that, we get this new technology. Yeah. In first instance, we need all this complementary stuff, and it's just hard for companies to do this, and therefore they actually don't see productivity effect, not just from a measurement perspective, but also just because it's complicated.
Yeah.
But once they got it right, they do get it. So my question to you is, do you think that's factored into the way that you are looking at the J curve, or is that an additional effect that could make the J curve worse or could lengthen it over time?
Honestly, I think it is the same thing. I think it's relabeling. All this, it's hard to figure it out stuff. You could say that's making all this intangible capital. Those are all resources that companies are spending trying to figure out how to use the new technology. Not every dollar is tied directly to some positive thing that pops out. Money is something turns out not to work. There's trial and error, stuff like that. But I think you could call all of that just expensive ways of building intangible capital. But I agree, there's a real story there, which is a real, not meaning real like not fake, but real like not just accounting. That, yeah, you can be in a world where everyone recognizes there's this new technology, has some sense of all the potential it's got, but then is puzzled about like, well, why aren't we seeing all these great things happening with it? We, in the accounting story, would say, well, they're making intangible capital. You're saying they're fumbling around trying to figure out, those are, to me, are the same thing in some sense, but it's not to say it's just a problem with our bookkeeping. It's like, yeah, people are going to be busy accomplishing nothing for a while. I guess that is one way to think about what happens. So that's a fair interpretation.
Hi, Leonard McNamara, Federal Reserve. Leonard McNamara, Federal Reserve Bank, Philadelphia. This is in the last 10 years or so, people have been talking about a manufacturing productivity slowdown. In fact,
yeah,
the industries that do a lot of R&D.
Yep.
Has that changed in your look at the post-COVID era, and what do you think that slowdown is about in terms of the framework?
Great questions. It's true. Measured productivity growth in manufacturing has slowed down. Manufacturing used to exceed the aggregate productivity growth number pretty consistently. I don't think we know why. I don't know if it's changed since COVID or not. Joey Politano just wrote a nice blog post on it. I haven't had time to read it yet. He's got the most up to date. But part of Austin's and my project going forward is going to be looking at some manufacturing specific industries, trying to figure out maybe what's going on. So you raise a great issue. I'm afraid I've got nothing to offer by way of answers.
Thank you. Thank you very much for an excellent presentation.
Welcome.
I enjoyed the knowledge and scholarship that you shared with us. Thank you very much for that. My question relates to the role of market power in this whole story. For two reasons. One, intangible investment and market power are interconnected. The other reason is the TFP has the market power has the implications for TFP, and this has been discussed in the regional by all cultures and other Morrison. if we want to incorporate market power into this story, what do you expect to change, and what do you expect to remain in your findings?
All right, great question. And this also calls back to your question about rents back there, which I forgot to address. So thanks. I'm actually, so when I'm not doing productivity, or sometimes when I am doing productivity, I'm an industrial organization economist. So I think about market power a lot. I'm actually writing a review of the markups and markdowns literature for the annual review of economics. So there's going to be more to come on the macroeconomics in particular of markups. I don't have a lot of time, but I think we can summarize it. It can affect productivity measurement insofar as if not the level of market power is like going to affect the level of productivity, but not its growth rate if it's steady. But if it changes, if it's been increasing, as some people have said, it could be part of the productivity slowdown. I know DeLuca, Eckhout, Unger talk about that briefly in their paper. Quantitatively, how big of an issue that is, I don't really know. I don't actually think it's a big thing, simply because the productivity slowdown is worldwide, but we have pretty large variations in implied market power across different sectors. But it's not to say I know it's zero either. I think it's probably there. I just don't know how big it is. I think there are other things, even separate from productivity growth, tied to market power concerns that I don't want to ignore in general. But I think as a element of the productivity story, I'm not so sure it's a huge element. That's kind of my own reading of the evidence so far.
I'm representing from University of Liverpool. So I would go back to one of your first tables on business dynamics, because there was a literature which tried to explain slowing business dynamics with long-term processes, even increasing market power. Just to back to the previous question. So what would be your interpretation in the light of this improving business dynamics?
I don't know. I don't know why business formation's gone up 35% in the US, like over 6 months, and it stayed there. I don't know if anyone knows. If they do, they haven't told me. They haven't written a paper yet. I can't wait to learn more about what people find, but it's a mystery to me. I just don't know.
Thank you so much for the great talk. What are the few things for the demand side of the graph on that the general economic perspective, the market capital, and how do they work that into the aid, cost, and other? So, I mean, is there any connection between basically that side, the demand side of the firm, and the product side of the firm that we're basically talking about, and does it have any impact? I mean, I want to see if there's a connection between the two sides. Because I mean, if you read your paper, 11, the new paper, one of the key drivers of productivity is, for example, learning by doing. When achieve learning by doing is they can grow knowledge. Growing knowledge, of course, has to do with the investment on the demand side of the firm. Is it possible to basically clarify the link between the two sides? That side of that type of research and the research on productivity. I'm not sure if I think it would take it quite clearly, but
no, I get it. So I certainly believe at the microeconomic level, the demand-facing part of the firm doesn't get enough credit for the variations in measured performance, at least from we researchers who think about productivity. I think we think about productivity naturally based on how we learn about it as a supply side thing. It's how good you are at making the stuff you make. But it's also about selling and distributing when it comes to the profitability and maybe even correctly measured productivity of firms. I believe that conceptually, and I'm working hard right now with some co-authors to try to measure that, but it's way too early to tell you anything. Okay, but keep your radar out for that. Aggregate, it's a little tougher because if my good sales force just takes away sales from your less good sales force, that would have happened anyway. That's not really an expansion in aggregate output, right? That sort of business stealing element's a little bigger on the demand-facing side of the firm than the supply side of the firm. So translating as smoothly from micro to macro, as you might imagine on the supply side, isn't quite so easy on the demand side. Now, how much of it's business stealing, I also don't know. Maybe that'll come out in some of the work I'm trying to do or the work others in this room would love to do. But I think it's a great issue, and I'm trying to learn as fast as I can about it.
Let's just take 2 more questions. Stuff back there and then Richard.
So I wonder how much of this is to do with products changing over time, even though we think it's the same product. So a big part of that is, I think, that more products now internalize what would be externalities in the past, which sort of relates to the carbon point, but like more tangibly in construction, let's say, you know, in the 60s or 70s, there was a big pit and thrown in everything from the construction site, laid on top, and put the lawn down on top of that hole.
Yeah.
Nowadays, it all goes to waste management. That's a big part of the cost.
Yeah.
So this kind of externalities you now pay for in the final product, and it makes it less productive. But maybe it's possible.
Got it. Agreed. Conceptually, I actually did as part of the. We didn't put it in the paper, but people noted in a different kind of externality, fewer people die, fewer people are injured on construction sites than used to be. That's social value of output that we should be counting too. So I did the usual economist thing, which non-economists hate, is like multiply every saved life by $10 million, multiply every quality adjusted life year by $100,000. You add that up and you get 3% of output. So instead of having 50 years of decline ending up, you know, whatever, 20, how many ever, whatever percent below its 1970 value, you get 50 years of decline ending up whatever percent minus 3% below its 1970 value. So yes, it's there, but it turns out that particular externality, which you might think is a pretty big one, it matters, but it's just not that big. My guess is you add those other things you're talking about in, you're not going to rescue 50 years of negative productivity growth. We should count them, but that's not kind of the heart of the issue. Not to ignore it, but it's not quantitatively this issue. Yeah.
One question.
Richard Hayes, ONS, probably focusing more on some of the scope and measurement issues that I very much like Anthony's last question. Prefabrication for construction, I know something we've been looking at, which obviously we capture in manufacturing, but seems to be where the construction industry has been looking to find productivity and efficiency savings over time, and actually whether we should look at that sector in a combined fashion, bringing those together, and a thought around the food retail sector that you're describing. Very much at the moment, when I hit a Burger King or something like that, I'm now simply ordering off a big iPad on the wall and not seeing a member of staff, and whether that actually is just one of your intent and becoming visible and in play.
Yeah, good stuff. So the prefab stuff, I've talked to people in the, there's been a series of startups doing prefab. A lot of them have failed. For those of you who really want to get in the weeds, Brian Potter is the guy who writes a blog called Construction Physics. Amazing detail on technology of the construction sector. He goes through in some detail in a very plausible way, explains why prefab is not the easy solution you might expect it is. Not to say it could be, but it's not, oh, let's just start putting buildings together off-site and then rolling it up and we'll solve all these problems because we'll be manufacturing buildings instead of constructing them. I would just recommend that. I went into a McDonald's for the first time in a while. It physically looked completely different than it used to. There used to be a counter with 6 or 7 cash registers, 3 to 8 people standing behind it. Now there was one counter with one cash register. There wasn't anyone. They would, if you really wanted to order at the cash register, you could. But it's basically all the setup to either you put in your own order, or you've ordered online, and now the whole physical construction of the inside is, here's how you get your takeout order. There's a set of shelving and guides to go get your takeout order. If you want to go in and sit at the restaurant, you can. They'll actually bring the food to the table for you. So in some sense, that end of the service has actually gotten higher. But you can very clearly see physically, they're changing how they are actually making what they used to make. It really struck me. Even though, I mean, I'm working on the issue, I was still surprised how much things had changed. Okay.
Great, thank you very much, Chad. Chad's given us much food for thought. Now we're going to give you actual food. It'll be served just out by the registration desk in the mill. But before we head off, please join me in thanking Chad for a very stimulating talk. Thank you.